This is Recalculating Infusion Flow Rates. This is Shannon. So our example today is checking on a patient's IV to find that maybe the flow rate was not calculated correctly. So please take the time to read the example and familiarize yourself with the problem. The order was for 1,500 milliliters to infuse in 12 hours, and the flow rate was set at 25 drops per minute. The drip factor is 15 drops per milliliter. When you go and check on the IV, however, it has been 3 hours and 300 milliliters has been infused. It is now your job to decide if the flow rate should be changed, by how much the flow rate should be changed, and whether or not it is safe to do so. So let's take a look at this problem. The order originally was for 1,500 milliliters to infuse in 12 hours. But at the time that you enter the room, the order has changed. So what we're going to do first is find out how much infusion is left. That is, the original order was for 1,500 milliliters. We know that 300 milliliters has already been infused. We're going to subtract that and find that there are 1,200 milliliters remaining to be infused. Next, we have to talk about time. We know the original order was for 12 hours, and we know that 3 hours have passed. When we subtract these, we find that we have 9 hours left, or 9 hours remaining. So the first thing we did was find out how much of our infusion amount we have left, and then how much time we have left. This, in essence, becomes our new order. Our new order is 1,200 milliliters to be infused in 9 hours. I'm going to clear this page to give myself some new room. So we have our new order, 1,200 milliliters left to be infused in the 9 hours we have left. I'm going to set up our dimensional analysis. We know our drip factor is 15 drops per milliliter. I'm going to set it up so milliliters on top cancels with milliliters on bottom. I'm going to change my hours into minutes by using my conversion fact. 1 hour equals 60 minutes. My hours on bottom cancels with my hours on top. What I have left now is drops per minute, which I know is exactly what my flow rate should be in. So I multiply across the top, 18,000 drops. I multiply across the bottom, 540 minutes. When I divide the top by the bottom, I get my new setting of 33.3, or 33 drops per minute. Now, the important part of this problem is safety. Before changing a flow rate, we need to make sure that our change is less than 25%. So we're going to talk about how to do that here. Okay, so let's talk about this change in flow rate. So I have the rule written out here. A change in flow rate must be less than 25%, or we have to ask our physician if it's okay to perform that change. Mathematically, the way we find the percentage of change is we take our new flow rate minus our old flow rate. So in this case, our new flow rate found in the last part was 33 drops per minute. We can see from the problem that the machine was set at 25 drops per minute. That is the old flow rate. When I subtract those, I get a difference of 8 drops per minute. That is the change that I've made to the machine. I changed it from 25 to 33. That means I've changed it 8 drops per minute. I'm now going to take that and divide. So we're going to take that change and divide by the old. That is 8 divided by that old setting of 25. When we put in 8 divided by 25, we get 0.32, which is 32%. Now checking in with our safety rating, we notice that the flow rate change must be less than 25%. Because this is a 32% change, we would need to ask our physician and make sure this change is okay. So just to summarize, the steps we went through when recalculating the IV flow rate was first to determine how much of the IV is left to infuse. This will be in milliliters. How much time is left to infuse it in. This will be in hours. Then we determine that new flow rate by dimensional analysis. Of course, that flow rate will be in drops per minute. And then finally, we find that percentage change by taking the new minus the old and dividing by the old. That will give us a decimal, which we then change into a percentage to check against our 25% safety. Thanks for watching. I hope this helps.